Hello everyone. Today I'll be discussing my project on fake news detection using machine learning and why it plays such an important role. The topics we will be covering today include a brief introduction of the topic, the goal of the project, some information on different data sources, data models used, and then a discussion on results and interesting findings of the study before concluding. Let's start with the basics. Fake news has become a huge issue, especially in the digital age. It spreads misinformation, influences opinions of people, and poses significant challenges to information integrity. This project is an initiative to tackle the problem of fake news head on by using the power of machine learning and data analytics. Guard aims to distinguish genuine news from deceptive content with unprecedented accuracy and efficiency. Leveraging sophisticated algorithms like k-means clustering and naive-based classifiers, TruthGuard can analyze large volumes of data to identify patterns, detect anomalies, and flag potentially misleading information. The main goal of this project is to develop effective methods for automatically detecting fake news articles. This is crucial for promoting information accuracy, combating misinformation, and fostering a more informed society. The aim is to provide insights into the effectiveness of different models in identifying fake news accurately. This research findings will benefit a wide range of stakeholders, including media platforms, journalists, policymakers, and the general public. Accurate fake news detection is essential for maintaining trust in information sources and promoting responsible journalism. The data set for this research was compiled from two different sources. The data from the first source, Kaggle, was used to train the model, while data from the second source, News API, was used to test it. The training dataset from Kaggle was divided into two parts. The dataset with true news and the dataset with fake news. Combining these two files yielded a complete dataset. The testing dataset acquired via API was initially in JSON format, as we can see here in the first image, and it was cleaned and pre-processed by deleting extra amounts of columns after converting it into CSV format to fit it with the existing format of the dataset taken from Kaggle. Here, we can see the data collected from API before and after converting it into CSV format. The first image shows the raw API dataset, whereas the second image gives us an idea of how the final dataset looks after cleaning and combining it with the dataset taken from Kaggle. Data cleaning is a crucial step in the data preparation process. In the dataset collected, there were some null values in the text column, which is practically the most important column for our problem statement. Since the number of rows with the news text columns as null are quite less, they were removed from the dataset. After this step, before analyzing the data, it is important to understand what columns are actually important for the analysis. The columns containing site and image URLs are not relevant for this project as of now. Hence, those columns were removed. Once this is done, some other data inconsistencies and irregularities were handled accordingly. Moving on to data visualizations. Data visualizations helped in understanding different trends and patterns in the data. As we can see in the graphs here, the word cloud shows the most commonly occurring words. The bar graph right below the word cloud shows us the average title length by language. We can see that the news articles that are written in English and French tend to have longer titles as compared to the ones written in Spanish. The bar chart that is on the right side shows us the number of news articles we have in our data set that are coming from different sources. Moving on to data modeling, I've, as a part of this project, implemented several different data modeling techniques. Some of them are k-means clustering, hierarchical clustering, association rule mining, naive-based decision trees, and support vector machines. So k-means clustering groups data points into clusters based on similarity, aiming to minimize the variance within clusters. Hierarchical clustering builds a hierarchy of clusters by recursively merging or splitting clusters based on similarity or distance. Association rule mining can be applied in fake news detection to uncover patterns and relationships within large datasets of news articles, aiding in the identification of common characteristics or features associated with fake news. By analyzing the co-occurrence of words, phrases, or topics in news articles, ARM can reveal frequent items or association rules that indicate potential indicators of fake news. Naive Bayes, a probabilistic classifier based on Bayes' theorem, assuming independence between features giving the class label. The most commonly used kinds of naive Bayes models are multinomial, Bernoulli, and Gaussian. Decision trees construct a tree-like model of decisions based on feature attributes, enabling classification or regression. Support vector machines are powerful supervised learning algorithms that find the optimal hyperplane to separate data points into classes, maximizing the margin between classes. I do not want to go deep into the technicalities of these models. Instead, I will explain it as I walk you through the results of these models. Unsupervised, before jumping to the results, I would like to talk a little bit about supervised and unsupervised learning models. Unsupervised learning discovers patterns and structures in data without labels, while supervised learning uses labeled data to train models for predicting or classifying new data points based on known outcomes. As we can see here, K-means clustering model has identified the number of optimal clusters as 3, and when K is equals to 3, the clusters are well formed and the data is divided properly. How to decide the value of K? For this, I have used elbow method and silhouette method. The elbow method plots the variance explained as a function of the number of clusters. The elbow point indicates the optimal number of clusters, where adding more clusters does not significantly increase the variance explained. Silhouette method evaluates the quality of clustering by measuring the coherence within clusters and separation between clusters. It calculates silhouette scores for each data point, where higher scores indicate better cluster separation and cohesion. Based on these two, we've come to the conclusion that K value is optimally 3. Then we have hierarchical clustering. As discussed before in data modeling slide, this builds a hierarchy of clusters by recursively merging or splitting clusters based on similarities or distance. A dendrogram is created here to help us understand and decide the optimal number of clusters. We can also see a graph that shows the top frequently chosen rules that are decided after implementing association rule mining. Coming to the supervised learning models, I implemented multinomial and Bernoulli naive-based models. Naive-based often performs remarkably well in practice, particularly in the domain of text classification. Once the data was preprocessed and organized in the format required for the naive-based model, the algorithm was trained and tested. The multinomial naive-based model gave us an accuracy of 95%, whereas Bernoulli's performed even better, offering us an accuracy of 96%. We can see the confusion matrix of both these models over here in the slide, where we can see the number of true positives, false positives, true negatives, and false negatives, which will also help us in understanding the precision, recall, and accuracy of both the models. Decision trees are powerful machine learning algorithms widely used for classification and regression tasks due to their interpretability and ease of understanding. Understanding decision trees requires understanding the training process. Again, once the data preparation was done, the algorithm was trained and tested. This model gave us an accuracy of 92%, which is still really good, but not better than naive Bayes. We can see a simple tree structure created over here for the decision tree algorithm implemented. Moving on to SVMs, the core idea behind SVMs is to find the optimal hyperplane that separates different classes in a dataset with the maximum margin. In a binary classification scenario, this hyperplane acts as a decision boundary, assigning new data points to the one of the two classes based on which side of the hyperplane they lie on. Out of all the models, SVM performed the best. In SVM, I experimented with three different kinds of kernels. The linear kernel, all the three confusion matrix for the kernels are in the slide here. For linear kernel, we achieved an accuracy of 99%. For polynomial kernel, it performed even better with a 99.3% accuracy. And for RBF kernel, we have an accuracy of 99.4. Similar to the naive-based confusion matrix, we can see the number of true negatives, true positives, and false negatives and false positives here as well. So, in conclusion, the project on fake news detection using machine learning has demonstrated the power of advanced algorithms in addressing a very important issue of misinformation. By leveraging models like K-means clustering, hierarchical clustering, naive-based, decision trees, and SVM, we have made significant strides in accurately identifying fake news articles. While the results discussed are promising, there are some areas for further exploration and improvement. Further work could focus on combining multiple models for improved accuracy and robustness and integrating natural language processing techniques for better feature extraction and understanding of textual content. Accurate fake news detection is crucial for maintaining trust in information sources, promoting responsible journalism, and also in fostering an informed society. The findings of this project have heavy implications, as we discussed before, on different sectors of the society like media platforms and policymakers and journalists, and most importantly, the public as well. This highlights the importance of leveraging technology to combat misinformation effectively. I would like to wrap it up by thanking Dr. Amy Gates for her constant support throughout the semester, which made working on this project seamless and enjoyable. I hope you guys like my work. Please feel free to check out my website for more detailed information about this project. And thank you so much for your time.